Hey guys, welcome back. Today is day 57 and we're going to talk about quadratic formula today. So quadratic formula function is in the standard form of y is equal to ax squared plus bx plus c. Okay, when we graph a quadratic function, we actually get the shape of a parabola. Okay, if your a is less than 0, then your parabola opens down, and when that happens, you have a maximum point on the parabola. Okay, if a is greater than 0, okay, the parabola opens up and you have a minimum point. Okay, so we're going to start first talking about the quadratic formula. So what's really key to the quadratic formula is being able to understand and identify your a, your b, and your c. And we did this when we factored, okay, when we made the x. Okay, it works the same way. So again, standard form would be ax squared plus bx plus c. So in this first example, our coefficient before the x squared would be a 3. The b would be a -4, and the c would be a 5. Okay, so you're just looking at the coefficients, and then your c is your constant. So with example number 2, your a is 1/2, but in this example, your b is 0 because there's no middle term, there's no x term. So the bx would really be like a 0x, and then your c is 6. Okay, and example 3, we'd have your a is -2, your b is -6, and your c is -7. Okay, so what we're going to do with these values is we're going to start to use the quadratic formula. And the quadratic formula actually will tell us the two roots of the quadratic function. So you can think about it as the roots or the x-intercepts or the solution, or if you looked at the graph, so where it crosses the x-axis. So the formula that we're going to be using is we're going to be using the a, b, and c's that we identify. It's -b plus or minus the square root of b squared minus 4ac, a times c, all divided by 2 times a. Okay, now this formula will give you either 0, 1, or 2 solutions. Okay, you don't have to memorize the formula. We used to have to memorize it, but you guys are given it, especially when you take your SOL, you'll have that given to you. Okay. So let's look at an example. So the first thing we always have to do is rewrite the equation in standard form. Many times it's already given to you in standard form, but this particular example, we need to move the -14 to the other side and solve for 0. So we're going to start by, okay, adding 14 and setting it to 0. Okay, so when we do that, we can easily identify our a is 2, our b is -12, and our c is 14. Okay, so from there, we're going to start using the formula. Okay, so when we do that, we've got negative, if you look at this, it's x is equal, we're going to substitute in a -b. So if I look at the b value is -12. So eventually that -12 will become a +12. We're going to take that b, which is -12, we're going to square it. Then we're going to take the number 4 times our a, which is 2, and our c is 14. All divided by 2 times 2. Okay, so we're just plugging these values in. All right, so a -12 is actually +12, plus or minus the square root. Okay, so -12 squared is 144. Okay, minus, now 4 times 2 times 14 is going to be 112. So we're going to subtract 112. Okay, and we're going to divide that all by 4. All right, so when we go to simplify that, we've got 12 plus or minus the square root of 32 divided by 4. Okay, now the square, this is where this plus minus comes in. Okay, the square root of 32 is not a perfect square. Okay, we're going to round and just use the number 5.6. Okay, so the square root of 32 is between 5 and 6, or it's 5.6. All right, but it's positive and it's negative. So this is how we branch out to have 2 solutions. We're going to say 12 plus our 5.6 divided by 4. And then we're going to branch to 12 minus 5.6 divided by 4. Okay, so when we calculate the top one, we're going to get a solution of 4.4. All right, and then the bottom one will be the solution of 1.6. So our answers would be 1.6 and 4.4. Okay, and that's approximate. We're just rounding to the nearest tenths. Okay, so we can also check this using Desmos, okay, because we can graph this, and this comes in very handy. So we're going to quickly just go over here and let me pull up my graphing calculator here. All right, so I'm going to just move this over. Hold on a second. Okay, whoops, let's get it fitting in there. There we go. All right, so I am going to put in there, all right, and I actually already did. I put in 2x squared minus 12x equals negative 14, but I'm just actually going to add 14, okay, and we're going to look at the parabola, okay. So if we look at the parabola here, you can see, let's make this a little bit bigger, there we go, okay. All right, so if you notice, we cross, this parabola crosses right here at 1.58, which is about 1.6, which is what we said, and then right here, which is 4.4. So you can see it crosses the x-axis at those two values. Now this parabola actually has a minimum low point, okay, and that would be at negative 4. All right, so it's got a minimum. The domain, okay, the x values would be all real numbers, and the range would be any values greater than negative 4. Okay, so moving on, let's try a few. Okay, so with number 4, we've already captured a snapshot of the graph, so we can tell already that we think our solutions are going to be right here where it crosses the x-axis. So it looks like it's at about 1 and 2. Let's see what happens. So our A is 1, our B is negative 3, and our C is 2. Okay, so we're going to start out and say negative b, which is positive 3, plus or minus the square root of b squared, which is going to be 9, minus 4 times a, which is 1, and c is 2, all divided by 2 times 1. Okay, so then this becomes 3 plus or minus the square root, 9 minus 8 is 1, divided by 2. All right, this is where we branch out and we say this is going to be 3 plus 1 because the square root of 1 is 1, divided by 2. And we've got 3 minus 1 divided by 2. 3 plus 1 is 4. 4 halves is 2. 3 minus 1 is 2. And 2 halves is 1. So we can verify that our solution is x is equal to 1 and 2. Okay. In this case, our domain, our x values, can be anything. So we're going to say x is an element of the real number set. And the range is actually going to be your y values. So you look at the point right here, which is the vertex, the very low point of that parabola. And our range is going to be greater than or equal to 0.25. And in this case, we have a minimum, all right? Meaning a minimum value there. The vertex goes down, okay? All right. Looking at number 5. Again, we're in standard form. We identify our A, our B, and our C. Okay, we're going to put it into the quadratic formula. All right, and we do that by saying negative B, which is negative 2, plus or minus the square root of B squared, which is 4, minus 4 times 1 times negative 3. And that's all divided by 2 times 1. Okay, so that simplifies to be negative 2 plus or minus the square root. This is 4 plus 12, which is 16, all divided by 2. All right, now the square root of 16 is going to be 4. So we're going to branch off and say negative 2 plus 4 divided by 2. And then we've got negative 2 minus 4 divided by 2. This is going to be 2 halves, which is 1, and this is going to be negative 6 halves, which is negative 3. Okay, so when we look at our solution, we've got x is equal to negative 3 and 1, and let's verify that with the graph. We cross here at the x-axis at negative 3 and here at 1, so that does work. Again, our domain would be all our x values, can be anything because that parabola is going to continue on and on and on. In our range, though, if we look at our y value, our y is going to be greater than or equal to negative 4. That's our range. And again, at this case, we have a low point, so we have a minimum. Okay, so moving on, we have number 6. Okay, number 6, 2x squared minus 7x plus 6. We're going to identify our a, b, and c. Our a is 2, our b is negative 7, and our c is 6. Okay, so we're going to put it into the quadratic formula. All right, negative b would be a positive 7, okay, plus or minus the square root of negative 7 squared, which is 49, minus 4 times 2 times 6. All right, all divided by 2.2 times 2. All right, so that's going to simplify to be, and we'll just kind of go up here for this one, 7 plus or minus the square root, 49 minus, and this will be 48 because 4 times 2 is 8 times 6 is 8, so 49 minus 48 is 1, okay, divided by 4. All right, so when we branch out, we've got 7 plus 1 divided by 4, and then we also have 7 minus 1 divided by 4. All right, running out of space here, but 8/4 is 2. Okay, so our solution is going to be 2, and then we have 6/4, which is 1.5. So 1.5 and 2 would be our solution. Now, if we look at our x, where it crosses the x-axis at those 2 points, we've got 1.5 and we have 2. Again, our domain is going to be any value, so all real numbers, and the range, we look at our y value, is going to be greater than or equal to negative 0.125. And again, this has a minimum. Okay? Now, at any point, you might want to try by stopping and trying to do one on your own. So if I look at number 7, I identify my a, b, and c. I've got 2, 9, and negative 5. All right, so my negative b is going to be negative 9 plus or minus the square root, and we've got 9 squared, which is 81, minus 4 times 2 times negative 5, all divided by 2 times 2. Okay, so this becomes negative 9 plus or minus the square root, and 81 plus 40, because we got a negative 4 times negative 5 is negative 20, times 2 is 40, so it's 81 plus 40, so we're going to get 121. Okay, we're going to get 81 plus 40, which is 121. All right, and that's going to be divided by 4. All right, we're going to branch out and say negative 9. The square root of 121 is 11, so we're going to say plus 11 divided by 4, and then negative 9 minus 11 divided by 4. All right, so we end up with negative 9 plus 11 is 2. 2/4 is 1/2. And then we've got negative 20/4, which is a negative 5. So our solution here would be x is equal to, and we've got a negative 5 and 1/2. Okay, so if we look at our graph, you can notice x-axis is up here, but we're crossing right here at negative 5, and it looks like 1/2, so that works. Again, our domain is our x values are going on and on forever, so that's going to be element of the real number set. And the range is going to be anything greater than, so it's going to be greater than or equal to negative 15.125. And again, this has a minimum. Okay, moving on. Okay, number 8. Now, number 8 is not in standard form, so the first thing we want to do is put it in standard form. So we'll say 3x squared plus 9x minus 4 is equal to 0. Okay, our a is 3, our b is 9, and our c is negative 4. All right, when we put it into the quadratic formula, negative b is going to be a negative 9 plus or minus the square root of b squared, which would be 81, minus 4 times 3 times negative 4, all divided by 2 times 3. Okay, so from there, okay, we're going to simplify this to negative 9 plus or minus the square root, and this is going to be 81 plus 48. All right, all divided by 6. Okay, when we take the square root, 81 plus 48, we're going to get 124. The square root is going to be 11.4, so we're going to branch out. Let's simplify this again, just so you can see. So it's going to be let's see, 129 rather. Okay, over 6. We're going to branch out to negative 9, and it's going to be plus 11.4 divided by 6, and negative 9 minus 11.4 divided by 6. Okay, so when we simplify that, we get 0.4, and the bottom one we're going to get negative 3.4. So our solution is negative 3.4, and 0.4. Okay, and if we look at our graph, that shows it's just about right. Okay, so our domain again is x is an element of the real number set, and the range values are going to be anything greater than, so our y is always going to be greater than or equal to negative 10.75. And again, this is a minimum. All right, so in contrast to that, looking at the next graph, you can see how it's shaped the other way, and now we actually have a maximum. Okay, so that's the difference between min and max. And the domain in this case, our x values, again, are going to be the element of the real number set. But our range in this case is always going to be less than, okay? So it's going to be less than or equal to negative 5.75. Okay? Looking at this example, you notice that this is negative 5, this is negative 6. This never crosses the x-axis. So this indicates already that there's no solution here, or no real solution, let's say. All right, let's verify that. Okay, we start out by putting this into standard form. So we've got negative x squared minus x minus 6 is 0. And we get a negative 1, and negative 6. Okay, when we put this into our quadratic formula, we have negative b, which is positive 1, plus or minus the square root of negative 1 squared, which is 1, minus 4 times negative 1 times negative 6. All divided by 2 times negative 1. Okay, when we do this, all right, underneath the quadratic, we have 1, and it's going to be minus 24. Okay, so what happens here is 1 minus 24 is a negative 23. Okay, we can't take the square root of a negative number. Okay, so right in here, what's under the radical sign is known as the discriminant. Okay, and we're going to look a little bit at the discriminant. If that discriminant is less than 0, there are no solutions. Okay, because we can't take the square root of a negative number. All right, if it's equal to 0, that's when we have one solution, and if it's positive, that's when we have our 2 solutions. So that discriminant is important. Okay, and the discriminant is known as, right here, just b squared minus 4ac. What's underneath that radical sign? Okay, so if that value right here is greater than 0, you're going to have 2 solutions. If it's equal to 0, you have 1 solution. And if it's less than 0, we know we can't take the square root of a negative number, so that's when we have no real solutions. Okay, highly recommend doing all of the practice problems today, okay, and working on the study guide because our test is in 1 week. All right, so we will review next class, and we'll also work on the curve of best fit, so using data and maybe doing some word problems. All right, thanks so much. Bye.